Welcome to Renosa's Monthly Power Insights. As your trusted Pacific Northwest manufacturer's rep in the emergency power generation industry, we are proud to offer expert guidance on genset components. Throughout the series, we'll explore how to optimize system design, select the right equipment, and support uninterrupted power. Whether you're an engineer, specifier, or project manager, we're here to help you design smarter, install more confidently, and keep the power on when it matters most. Let's dive in.
All righty. Well, thank you guys so much again for putting this on. These monthly videos, I think, will just really go a long way, and I hope they're helpful for anyone that's got questions. I know dual fuel is becoming more popular with the emissions and standards that are moving around. So again, thank you very much. My name's Nick Walsh. I'm a mechanical engineer here at Eden Innovations. My main product here is the OptiBlend dual fuel kit. Eden does have a couple of other products here. These are the Edencrete and the Eden Plast you see at the bottom. OptiBlend is what I'm here to talk about. This is our dual fuel solution for diesel generators, or at least constant speed diesel engines. Edencrete and Eden Plast are two products that don't really seem related to OptiBlend, but I'll tell you how we got there. Back in the day, if you remember, it was looking like the world was going to go hydrogen fuel cells for vehicles. However, we seem to have gone EV, but we were after the hydrogen. And in that process, we learned how to separate hydrogen from natural gas. It's a process called pyrolysis. And we were making a drop-in fuel blend called Hythane. It was a hydrogen-enriched natural gas drop-in fuel replacement for vehicles, for over-the-road vehicles. And in the process of pyrolysis, this is basically the thermal decomposition of methane. So we're breaking down natural gas into its constituent components, one of which being hydrogen, and that's what we were after. However, another byproduct was this black dust that turned up in the bottom of our reactors, and we didn't know what it was, so we sent it out for testing, and it turns out it's carbon nanotubes. Super valuable product, certainly viable. So what the heck do we do with this stuff? Well, we put it into concrete, and that's what we have for Edencrete. Various product lines along there, but basically we're after either strength or abrasion resistance, crack propagation resistance, things like that. And put the carbon into plastics. That's Eden Plast. So seems like they're unrelated products, but here at Eden, we are working on some cool, innovative products. So let's talk about OptiBlend and what we're here to learn about. Dual fuel, bifuel, what is it? What are we talking about? This is just the substitution of diesel with an alternative in your normal internal combustion engine, whether it's diesel or a spark ignited gas engine. The theory works. We can use this alternative fuel to make up the energy. So you take out half the diesel, you're losing that energy. This alternative fuel makes up the difference, whether that's natural gas, propane, butane, what have you. The theory of operation is exactly the same. The engine uses less diesel to produce the same amount of power. So we're efficient use of the diesel at that point. And there's a few different methods for doing dual fuel. And there is technically a difference between dual fuel and bifuel. Everyone in the industry uses the terms synonymously. It's completely fine. They are more or less interchangeable. But technically, bifuel is an either-or situation. So you are either running 100% diesel or 100% alternative fuel, whether it's natural gas. I'm pretty much going to reference natural gas. That's what we do mostly. But no, anywhere I use natural gas, you can substitute for propane, for instance. So bifuel is the either-or situation, as opposed to dual fuel, which is what OptiBlend is. This is where you're running both fuels simultaneously. So we are always running a minimum amount of diesel to keep the engine healthy, lubricated, and all of that. And then we're just substituting the extra gas, substituting with gas, and up to 50 to 70%. displacement. We guarantee 50%. I've seen engines run 60, 70%, and we have a hard shutoff at 70%. And that's for the health and safety of the engine. So the two methods that you can use is fumigation or direct injection. Direct injection is kind of the more intrusive to the engine, more expensive, more complex, but it is more precise. You can really play with injection timing to reduce, if not eliminate, methane slip, which is just unburnt methane going out of the stack. So if you don't get a complete burn in the combustion chamber, some of that's just going to go out of the exhaust, especially at lower loads when the engine's not as hot. So with direct injection, you have another injector. So one for the diesel, one for the gas. So this is why it's invasive, it's complex, very expensive to install, but they're nice. It is fancy. The fumigation method is just a much less invasive, simple, it's cheap. All we're doing is basically removing the air intake, tubing, plumbing, what have you, and inserting a mixer. So gas is drawn into the engine. It's never forced in under pressure like you would with a direct injection system. That's inherently safe, right? If there's a leak on a high pressure injection system, it's just going to fill up the space, whether that's the enclosure or the room that it's in, you're leaking gas, as opposed to this low pressure system where you need to see suction from the engine for the gas to be drawn in. If you have a small leak, the leak tends to just get sucked into the engine instead of just filling up the cabinet. So it's simple, it's cheap, it's safe. It's a great method to do. So that's what OptiBlend is. We are a dual fuel fumigation system. Again, people call it bi-fuel, our feelings won't be hurt. So OptiBlend, typical performance curve here. I was saying how we are a dual fuel. We're always running both fuels, and that's what we're looking at here. So when the engine starts, we have no gas on it. It's diesel, 100% diesel, so you retain your diesel startup time and all of that kind of stuff. And then as load comes up, we'll introduce gas more and more until we're into the meat of the range here. This 30 to 70% engine load is where we're going to get our maximum offset, our maximum fuel savings. And then as loads continue to increase up to 100%, then we start to taper gas off. And this is, again, for the health and safety of the engine. We want to keep temperatures down. Exhaust temperature, of course, is going to rise, just the chemistry behind burning natural gas versus diesel. So that's what we're limited by at the top end here. So startup, no gas. As we increase maximum amount of gas on the engine, and then taper off. So what are we after? Why are we doing this? Various different benefits, various reasons. It kind of depends on the industry you're in. So you can have a very quick return on investment. For the prime power application guys, this could be your oil fields, your frac trucks, where they're running the engines 24 hours a day at heavy loads. If we can cut that diesel usage in half, their ROI can be a matter of days, weeks, or hours. It really can pay for itself. Lower capital costs versus a natural gas engine. If you guys are in the industry sizing generators and pricing generators, then diesels are always smaller and cheaper than the natural gas engines. They require a lot less maintenance as well. So you can dramatically improve our backup power capacity. If we're cutting the diesel in half, then your on-site storage tank will either last twice as long, or you can have a smaller on-site storage tank. Some areas of the country, the EPA says, hey, you can only have X amount of gallons on site or underground, what have you. This also allows you to be less dependent on diesel deliveries. And we found this during Hurricane Sandy some years ago, where the Northeast just got hammered and everyone was running out of diesel. Well, if you're not at the top of the priority list for the diesel deliveries, you might be waiting. So if you can have your tank last longer, then of course you reduce your dependence on those deliveries in the emergency situation. And then, of course, emission reduction. Just the chemistry behind burning natural gas versus diesel, we're going to reduce nitrous oxides, particulate matter, and CO2, which leads me into this diagram here. Again, just a visualization of exactly what I said. NOx, PM, CO2, they all come down. Carbon monoxide is going to go up by a factor of 5 to 10. It's just matter of fact. Unless you use a diesel oxidation catalyst or an exhaust package, then we can get the CO down. CO is one of the easiest compounds to catalyze out. So this is not a problem, but it is worth noting if you're doing this for EPA Tier 4, for instance, you will fail for carbon monoxide. But we have catalyst partners that we've used in the past and can get those down. And we have done Tier 2 to Tier 4 upfits before, again, partnering with a catalyst provider. So we were able to meet the most stringent EPA regulations. Just be aware, though, with an exhaust package. I don't think there's much else to say here. Yeah, we'll keep moving. Applications kind of all over the market as far as data centers, hospitals, warehouses, oil rigs. I mean, anywhere that has a large diesel generator, basically. We're in all the fields. So the data centers and the hospitals, they're really after the extended runtime and reduce operational costs. They might be harping on emissions. However, it's usually about having a smaller diesel tank or extending that runtime because they're backup generators that might not be used that often. They're not necessarily after a return on investment. They could have a green initiative, so they're ticking the box for the EPA for emissions, for instance. The prime power guys, these are the guys that are after saving money, really, and that return on investment. Oil rigs, frac pads, all of that. I was out at a frac pad that had 19 engines running full load, 100 gallons of diesel each. They were burning 4,000 gallons or $4,000 an hour in diesel. So if we can cut that in half, the kit pays for itself in hours, kind of deal. So the prime power, yeah, they're after that return. Of course, environmentally sensitive areas, if we have smaller diesel tanks, lower emissions, that might get us a foot in the door, as opposed to a full natural gas engine as well, larger footprint, more maintenance. Retrofitting a diesel to use both diesel and natural gas might be a better alternative than a full gas engine in these environmentally sensitive areas. More on that point. Reasons that we would prefer to go dual fuel versus a full nat gas engine. They're big, they're expensive. In the past, I don't know if this is true anymore, the full gas engines just cannot meet the diesel response time. So in hospitals, for instance, they have a mandate that in a power outage, the generators need to come online and grab the bus in, I think, 10 seconds or less. Most natural gas engines, or at least at the time, no natural gas engines could meet that response time. So they would have a diesel engine on standby that comes online, grabs a bus in 10 seconds, and then sheds that load to the full gas engines. You can do away with that if your engine is dual fuel. Again, it's no gas on startup. So you retain that response time, get on the bus nice and quick, and then you don't have to shed load to full gas engines. You would just run the engine in the heart of the range at 30 to 70% load range, and then you're getting good displacement of the diesel. Again, less maintenance in general. The gas engines, they're going to have spark plugs and they're going to burn up. You're going to have to replace them. Retrofitting our kit does not add to the maintenance time or costs of your diesel engine. You just retain your normal maintenance procedures and then check the filters on our gas train once a year, once every 6 months, kind of depending on usage. So we're a very low maintenance system. Certainly a lot less maintenance and a lot cheaper maintenance than working on these large gas engines, gas only engines. Here's kind of a depiction of the theory of operation here. Gas comes in on this green line here. This is our gas train. It's just a ball valve, a filter, an electric solenoid, and a regulator. And then we have a throttle or a gas control valve either on the end of the gas train or on these mixers here. Mixers are installed between the air cleaner and the turbo. So upstream of the turbo, downstream of the air cleaner. This is where gas is actually drawn into the system. Again, we are never directly injecting gas under pressure. We're waiting for suction from the engine to draw the gas in. So air obviously comes in through the air filters, gets mixed with the gas here, and then pumped into the turbo. And the turbo turns out is a very good mixer. So you get a nice mix before it dumps into the combustion chamber, into the engine itself. We have a little PLC. This is the brains of our operation here, looking at all sorts of different signals, vibration, exhaust temperature being the main one. But we are also obviously monitoring load and frequency or speed of the engine. It's all displayed here on our HMI. A nice rugged display. These work in the oil fields. They're meant to live outside and they're push button instead of touch screen kind of stuff. Things that are just rugged, and the oil fields really put our kits and components through the ringer. So they're ruggedized. I guess it's worth noting here as well, this is your typical layout with a single gas train, one mixer per turbo. This is a depiction of a two turbo engine. The larger engines, we might have two gas trains, four mixers, so a four turbo engine. It just depends on size. This is a 2-inch kit here. We have 1 inch and 3 inches. Typically, you're going to be in the 2-inch range or two 2-inch kits. Just worth noting there. Highlights. No sacrificing of performance. This is 100% true. Whatever your diesel engine can do, you will retain all those capabilities. You will just do it with half as much diesel. No derating of the engine. In fact, we cannot tell an engine to do anything. We can't shut an engine down. We cannot derate an engine. Nothing like that. Our alarms are set softer than the engine's alarms. So if anything starts to go wrong, our kit's going to shut off and your engine will be back on 100% diesel in an instant. Another good thing to note, you can always just come by and turn gas off, and now you just have a diesel engine, as if it had no kit on it. There's no problems doing that. You can do it while the engine's running. You don't have to restart anything. You can just close the solenoid, close the ball valve, what have you, and you will be back on 100% diesel. No loss in response or reaction time. I touched on that with the natural gas engines and the hospitals. It's absolutely true. As I said, I think it's changed now. The full nat gas engines might be able to get on the bus now. That's just a recent anecdote that I've heard from somebody in the field. But it is a big advantage having a diesel engine that can grab the bus in less than 10 seconds. We're able to handle variable load swings, large load swings, block loads, whatever you want to call them. This comes up a lot in the oil fields when they're tripping pipe, for instance. They're pulling the drill string out of the ground. The engines will load up. All four engines will load up 80 to 100% until the drill string's pulled out. And then once it's out of the ground, the load comes all the way back down to near zero. So we have these large block loads on the engines, and our kits are able to sense that and make adjustments. No OEM control system modifications. We tie into the OEM controller often to get signals, but we don't. There's There's nothing that needs to be done on the customer side, on the OEM side. It's basically just a terminal strip inside the cabinet that we land our wires on to get the signals we need. Again, reverting back to 100% diesel, that's just a great advantage. Can do it on the fly. This one's interesting too. Running field gas. We have what we call AGC, adaptive gas correction, where you're able to actually, if you're fracking, for instance, and you're pulling the natural gas out of the ground, you can essentially pump that right into our kits. I mean, you got to clean and dry it, of course. You don't want to just pump dirty gas into the kit, but pull the gas out of the ground, put it into the kit, you're fueling your own operation at that point. That's pretty awesome. And field gas, we have no idea what's coming out of the ground. I mean, we can get a gas analysis, but who's to say you don't hit just a pocket of methane, for instance, or propane? What AGC is able to do is see what we call like hot gas, a higher energy fuel coming through than, say, mostly methane. Maybe you're getting 80% methane out of the ground, and all of a sudden it's 80% propane. Propane and the higher energy fuels like that are going to knock an engine sooner than methane. So adaptive gas can see that the engine's trying to overspeed and that you're getting a lot of energy output, and it'll trim the throttles down and allow less gas into the engine. That's what we're calling adaptive gas correction. So the fracking guys really like this. This is just a list to show you we can work on pretty much any engine, any size. The smallest generator that we've done was 20 kilowatts. Gonna call it a little suitcase kind of thing. I think it was just powering some lights around a rig. And we've done all the way up to 4,000 kilowatts. That's not necessarily the limit. That's just the biggest that we've done so far. And you can see all the manufacturers and model numbers there. Again, this is just a snippet. We've worked on just about anything out there. I don't see Perkins on the list here. We've done a couple of Perkins engines, for instance. So very, very well adapted. We can retrofit your existing generator or go on a brand new install. That's no problem. Size, not really an issue either. And the rest of the presentation here is just pictures. I think it's worth seeing them in the real world. This one's a nice yellow cat. You can see here, this is our control box, stainless steel, the rugged one. Just mounted right on the OEM control cabinet. The panels on, this is our main harness here. This is our panel mounted on the side. And this is showing same engine, control box here, panel over here. This is our mixer with the throttle right here. And then the gas train is mounted low along the frame. This is a 2-inch gas train, single turbo setup. So one gas train going to one mixer, again, upstream of the turbo, downstream of the air cleaner. We put it right in there. And then you're able to control our kit right here. The OEM screen is right here, so you can stand in one place and operate everything. The next is, this is an MTU, a larger engine. I was mentioning how you could have multiple gas trains on one engine. That's exactly what we're seeing here. Picture's a little washed out, but the gas trains are low along the frame down here. So we have one gas train feeding 2 turbos on this side and one gas train feeding 2 turbos on the other side. Again, 2-inch kits, 2 gas trains, 4 turbos, 4 mixers. Mixers between the air cleaner upstream of the turbo. These are our turbos down here. We were able to just mount nice and clean there. Here's a similar setup to the MTU, or a similar size generator anyway to the MTU. We have 2 gas trains. This time we hung them from the ceiling. One gas train feeding 2 turbos on each side. Again, very similar setup, and it's meant to just show we're adaptable. We can put these gas trains anywhere. We have stands if you don't want it mounted on the engine. We can mount it on some strut off the frame, off the ground, or hang it from the ceiling here. Here's some these two are oil rig photos. custom engineering is kind of what we're pointing out here. So instead of having the nice stainless steel box, we actually integrated our entire HMI into the OEM panel. So this is the OEM controller here with our screen mounted right in there. And again, I mentioned a stand. That's what this white bit is here. They look a little different now, but same concept. Basically, we just don't have anything mounted to the engine except for what needs to be there, the thermocouples and the mixers kind of deal. HMI mounted on the front, panel right on the back, gas train on the back here. So this is our gas train back here. They have these blue jackets on there. Those are the cold weather kit. That gives us the capability to run down to negative 40 degrees C or F. Again, custom engineering, very adaptable. We can kind of work with anything you got there. I've yet to be stumped on getting one of these kits on an engine. Here's a frac truck. Gas train is here, again, behind the blue cold weather package jackets. So our entire gas train's back here. Screen is mounted over here next to the OEM controller. This yellow cable here goes to a vibration sensor. That's ours. This is our panel mounted here. And this is just to show ruggedness. I mean, these things are meant to live outside in the weather, in the elements. They're meant to be beat on. Well, they're not meant to be beat on, but they can take a beating kind of thing. Again, frac truck, oil rigs, 100% or a 24-hour a day operation kind of thing. This one's a hospital. Again, kind of showing you the different capabilities that we have. For in this one, the problem we ran into these gas drops here. You can see they're next to each engine. There were 4 engines in here. These are Cummins. These gas drops were a different distance from each engine. So instead of having a nice clean gas train all bolted together, we had to break it up into separate parts. So valve, filter, solenoid, regulator with these manifolds that we actually built in the parking lot out there. Again, just trying to show you that we can kind of work with anything you got. A regulator on the end here, then you see the fuel hoses going to both turbos. We were able to work with the customer to supply parts for this and whatnot. But yeah, I've again yet to not be able to install one of these things. Another oil rig, just showing you, here's our custom engineering, quote unquote, built into the OEM cabinet. You can see how dirty and used. You can barely even see our green. Our mixers are actually green. So these things live out in the elements and just continue to work. Very, very reliable, rugged. And of course, any questions, comments, please reach out. And then Lori, if you guys have any questions, I'm all ears.
Thanks, Nick. That was great. Yeah, we do have some questions. So what would you say are some specific data points that are needed in the request for quote stage that we can kind of help our customers to make that part of the process smoother?
Sure. Yeah. Data that we need to at least get the ball rolling and get you guys a quote. Engine, make, model, and size. That helps us. If you can find out the number of turbos, that one's pretty big. It's usually the first question I come back with when they say, hey, I've got a Cat 3512, give me a quote. How many turbos you got? Unless we've done it in the past. But the number of turbos, that determines the number of mixers. So it has a direct impact on kit size and price. And then, of course, what do we need when we once you guys have bought something, who's on site? We ask that we have a gas plumber there the first day of the install when I'm there, or whoever is coming out to do the installs. So we'll need a gas plumber on site to tie into our kit. That's to take it from the gas supply, whether they've stubbed it up near the generator or it's not in place yet. They will make the final connection to our gas train. So I'll place the gas train and turn the gas plumber loose. That's day one. Having a load bank on site. So the last day of the install, we typically do the commissioning. We can install and commission at a later date, but cheaper, smoother if we all do it at once.
Sure.
Have a load bank on site capable of running the engines to 100%. If we're going to do them in parallel, it'd be good to see both or all of the engines in parallel up to 100%. We'll go from 0 to 100% load on the load bank in 10% steps, introduce gas at each step, take baseline readings. So need a gas plumber, need to have gas at the site. That's another one. I can't tell you how often I get there and there's no gas, or the meter's locked out. You got to call the city, or I can only get 1 pound of pressure and I need 3 to 5, kind of thing. So having gas on site at the right pressure, need to know what kind of engine you've got, in a load bank. I think those
Okay.
are the big things.
Great. Are there any barriers to be mindful of in terms of retrofit applications specifically, but in general, space, anything that you could say maybe is a tricky thing to be mindful of?
Not There's not too many things that will trip us up. Um, Communication protocol, that would be nice to know, going in if we are using J1939 to get data from the engine, or Modbus or 4 to 20 signals. A lot of times the engine spec sheet says, J1939 capable. Okay, cool. Well, did you buy that option, or did you just read the
Yeah.
spec sheet and tell me you have J1939?
Mm.
So those are good to know. Other than that, we really don't have trouble. Like space wise, I've always been able to find space. The size of the engines, we have kits that'll work on anything.
You mentioned
Whether
temperature is not really an issue.
Temperature's not
Mhm.
really an issue. We do have cold weather kits. So the kit on its own without the cold weather is good down to 5 degrees F. If you're going to be colder than that, say you're drilling up in North Dakota or something like that where it gets
Mhm.
below 0, we might want to throw a cold weather package on there. Um, EPA sensitive areas, I could see that coming up. If it's really stringent, tier 4, something like that, we can get you in contact with a catalyst provider. Whether the generator is in an enclosure or not, if it's outside or on a skid on the roof, no problems there. Manufacturer wise, no problems there. We've been on all the big ones. Yeah, I'm trying to
Yeah,
think if
I
there's
mean
any other
it's interesting
gotchas.
because for us, I'm sure this is running through Austin's mind right now
Mhm.
too, but um, for Renosa, we're able to also connect customers with a lot of those parallel products, if you will, uh,
Perfect. Yeah.
because we represent Mirror Tech. We can provide catalysts.
Mhm.
Um, if there's additional blankets that are needed.
Sure.
We have Furwin on our line
Perfect.
card and they're
You got a
fantastic.
guy
And
for
so,
that.
yeah, so that's great. I mean, and I'm just like listening to, load bank and all of that. We've got a lot of,
Mhm.
I don't know what to call, parallel, or supporting,
Providers. Yeah.
products. Yeah, that,
Yep.
that could kind of gel together here. Um,
Mhm.
And I know a lot of our customers like to just do one PO. So, or one project, get it all done. And so,
Sure.
we try to be a one-stop shop as much as we can at Renosa. And
Jason.
so, I'm just making those connections now as you're talking about that stuff.
Yep.
How about gas types? You mentioned the adaptive gas connection or correction, sorry.
Yes.
Um, and maybe this is a silly question, and I don't know if anybody would have the potential for it, but is there a way to incorporate, more than two fuels, if you will? Um, if that were an option for someone, could they
Mhm.
pipe in multiple gases, or is it just limited to, the diesel and something else?
Uh, yes and no. It depends. So you can use different gases, i.e., methane or propane, kind of
Okay.
deal. As far as if you had some sort of blend of those, this is kind of where the wellhead gas comes in, where we don't
Yeah.
really know what's coming out of the ground. So we're kind of able to handle variable gas content
coming in
to a degree.
Mhm.
We do have what do we call them? Like gas specifications. You want to be within a certain range on some things. Um, as far as, typically we're getting gas from the city, so it's methane for the most part. Now, if somebody were to make their own blend, say they had a tank of propane and a tank of natural gas, they were to
Mhm.
blend them and deliver it to our kit as a blend, I think it'd be something like they'd send us a gas analysis. We could look at the energy content and kind of tell you what to expect. With
Okay.
natural gas or methane, we are guaranteeing 50% displacement of the diesel. With propane, absolutely not going to happen. You will knock
Okay.
an engine long before that. So if you have some sort of combination, um, talk to us basically, and we'll see if it would work. As far as having separate sources fueling our kit, I would be hesitant to do it. Like, say you had a tank of propane and a tank of natural gas. One
Mhm.
day you want to run the natural gas, one day you want to run the propane. Theoretically, it would, like, the theory of operation works, but the settings that we have for their kit, our fuel mapping, would
Gotcha.
not be quite right. So if you're at 50% load and we're getting 50% gas, 50% methane on a kit, then when you go to hook up propane, our kit doesn't know it's running propane. So it's going to go to those set points and put too much propane in because it's going to
Gotcha.
knock an engine. Um, so as far as what gas you want to use, I would say only one at a time, and then talk to us about different blends. Natural gas, go for it. Everything I said is valid. Propane, butane, ethane, these higher energy fuels, you're not going to get 50% displacement. You will knock an engine sooner. So basically,
Okay.
call us and we'll work with you on it.
Cool. Let's see. Uh, Austin, did you have any questions?
No, thanks so much, Nick. It was super detailed and, really helped solve and illuminate all of my, little intricacies and questions. So thank
Good,
you.
good, good to do.
Sounds good.
Mm.
Well, thanks so much for taking this time with us, Nick. We really appreciate it. And
Yep.
customers, folks who are watching, if you have any
Mhm.
questions, feel free to reach out to us at Renosa. We are in direct contact with Nick and his team, and
Yep.
so we can make those connections and answer your questions pretty quickly.
Mhm.
And yeah, thanks everybody.
Yep.
Thank you. Thank you. All right.
Thanks.
See you,
Bye.
Nick.